Hello grade 8 learners, we are now in the new school year 2021-2022 and welcome to this new set of school year. So to begin with, our first, by the way, the discussion in mathematics of your grade 8 level. This is our module 1 with the topic factors, completely different types of polynomials and solves problem involving factoring. To begin with, we're going to acknowledge those writers here, those writers who developed this module for us to spread this lesson. We have here writer, contributor, editor, reviewer, illustrator. No, we don't have any illustrator, template, developer, the management team in our division. So thank you, teachers, who supported us in dealing this module. So to begin with, let us try to understand how to learn this first topic. So the main focus of this topic is know to factor completely different types of polynomials. Then we are going to solve problems involving factoring. So that's the thing that's the two main objectives in this module. Then we are going to start with the let us try. So in this we have here multiple choice. Read and analyze following items and choose the letter of the correct answer from the given choices. Write the letter of the correct answer on the separate sheet. So we don't have any separate sheet, so I will be able to encircle this, and I will explain further the situation given that we have. All the following expressions are perfect squares, except one. What is it? Is it A, x squared y to the 6th, B, 12a squared b squared, C is 16x squared y to the 6th, D is 25x to the 6th, y to the 8th. So the answer of this is we have B. So for that would be for number 1. I will change this one into encircle 1. So I'll encircle this one, by the way. For number 2 we have which among the quadratic trinomials is a perfect square trinomial. So we have here letter A, x squared minus 4xy plus 4y squared. B, we have 2x squared plus 2x plus 1. C, we have 2x squared plus 2x plus 4. And we have D, 4x squared plus 2x plus 1. So among these choices, we have here A as the answer. Okay. Next is we have what is the product of quantity x plus 3 times the quantity of x plus 2. I repeat, what is the product of quantity x plus 3 times the quantity of x plus 2? So we have here A, x squared plus 6x plus 6. B, we have x squared plus 5x plus 5. C, we have x squared plus 5x plus 6. D, we have x squared minus 5x plus 6. So we have here letter C as the answer. Next is we have what is the product of quantity y minus 7 times the quantity of y plus 7. I repeat, what is the product of quantity y minus 7 times the quantity of y plus 7? So here we have A is y squared minus 14, B we have y squared minus 49, C we have y squared plus 14, D we have y squared plus 49. So the answer here is B. And number 5 we have here, what is the product of the quantity 3x minus 3y quantity squared? Again, what is the product of quantity x minus 3y is equal x minus 3y quantity squared? So we have here A, x squared plus 6xy plus 9y squared. B, we have x squared minus 6xy minus 9y squared. C, we have x squared plus 6xy minus 9y squared. D, x squared minus 6xy plus 9 squared. So the answer is letter D. In the let us try. So I will explain this one little by little, so I will not be divulged first what will be the explanation among the 5 questions with a given answer. So let's proceed for a while with the let us study. So we're here in the let us study part. So in your grade 7 lesson, you have learned what they call finding the product of the polynomials. So let us recall first what are those special products that we have. So we have here the square of a binomial with a symbol or the pattern. Quantity a plus b quantity squared is equal to a squared plus 2ab plus b squared. Then we have quantity a minus b quantity squared. We have here a squared minus 2ab plus b squared. So what is that? What does it mean? So everything here, the a here is our first term. A here is our first term of the first factor. A here is the first term of our binomial expression. So first term, while b here is the second term. So how do we analyze this one? The first thing that we should do here is we're going to square the first term. So that we are going to square the a. Then to get the middle term or the second term is we're going to get the product first of the first and the second term, and then we're going to we are going to double it, or then the product we're going to have at twice of the product. Then to get the third term is we have here we're going to square the second term of the binomial expression. We also have the square of the first term, then twice the product of the first and the last term, or the second term, then square the last term, or the square the second term. Okay, here we have set another pattern, and it says quantity a minus b quantity squared is just the same as a squared minus 2ab plus b squared. So it means that we're going to square the first term, and then to get the second term is we're going to get the twice of the product of the first and the second term, and we have here negative. Copy the sign of the negative, or just to say the negative product of twice the product of the first and the second term. Then square of the second term, which is b squared. That's it. Okay. For example, we have here x plus 4 quantity squared. So our first term here, our a here is x, our b here is 4. Or just to say the first term is x, the second term is, or the last term is 4. So we have here square of the first, so which is our x. Since it is plus, so with the plus sign here, twice the product of the first term, which is x, and 4, and then square of the second term, or the last term. So we are going to finalize everything. So this is just the same as x squared plus 2 times x times 4. So 2 times x is 2x times 4 is, we have here 8x, plus this one must be, wait, I stand corrected, this one must be 4. So we have 4 square of 4. Okay, I will go the b, not the 4. So square of 4 is 4 times 4, which is 16. So the answer now is x squared plus 8x plus 16. Okay, another set of example, we have 2x plus 5 quantity square. So we have square of the first term, which is 2x, added twice the product of the first term, which is 2x, and the second term, which is 5. Then plus 5 squared. So we have here square of 2x, so we have here 2x times 2x, and that is 4x squared, plus this is plus 2 times 2x is 4x times 5 is 20x plus 25. This is how we answered everything given this pattern. Okay, next example is we have 3x minus 1 squared. So using this pattern, because it has a minus sign, so we have square of the first, which is 3x squared of 3x, minus twice of the first term times the second term, plus square of the second term. So we have square of 3x, and that is 9x squared. 2 times 3x is 6x, so minus 10 times 1, which is 6x, then plus 1. That is how we answered for this problem. Okay, next one is 4x minus 5y quantity squared. So we have square of 4x minus twice the product of the first term, which is 4x, times 5y, plus square of 5y. So we have 16 now, x squared, because it's square of 4x is 4x times 4x, and that is 16x squared. Then 2 times 4x is 8x times 5y, which is 40xy. Then square of 5y, and that is 25y squared. Okay, that is how we catered with the given binomial, square of binomial. So another thing is the product of the sum and difference of two squares. So represented by the first factor is a plus b, while the second factor is a minus b. Then the answer now is the square of a, the square of the first term, minus the square of the second term. So that's how we catered with this example. Okay, for instance, we have here x plus 1, x minus 1. This is minus 1. So we have square of the first. It's the first term here, and the first term, the second factor are the same as with 1 here, and the other one is 1. So the square of the first minus square of the second. So and we have here x squared minus 1. Another example, we have 2x minus 5, 2x plus 5. So we have minus plus or plus minus are still the same. So we have here square of the first, which is 2x, minus square of the second, which is 5. So we have here 5. So 4x squared minus 25, because square of 2x is 2x times 2x, and that is 4x squared. Square of 5, and that is 5 times 5, and that is 25. So then this one is minus. So that is how the given example takes place for the given pattern that we have, and that is quantity a plus b times the quantity of a minus b, which is the same as a squared minus b squared. So but here in our major concern in this given topic is what they call it, factoring. So factoring a given polynomial. For example, we have x squared plus 5x. So meaning to say, in this given that we have, so we're just return it back. So we are going to reverse the order. So we have here the given 40x. We have here the given we have here the given 4x squared plus 20x plus 25. So meaning to say, if we're going to reverse the order and what they call it, factoring, factor. So the answer now of this is 2x plus 5 quantity squared. Then the other one is x squared, the example number 1, example number 2, x squared plus 8x plus 16, and that is the reverse order now is x plus 4 quantity square. So we are going to square. So if we're going to reverse the order of the pattern, we call it now as factor. Then the third example is we have x squared minus 1. What's the factor of x squared minus 1? So the factor now is x plus 1 times x minus 1. The problem as I stated a while ago. Another one, number 4. 9x squared minus 6x plus 1. So as we factor it out, so the answer is 3x minus 1 squared. Then for number 5 is we have I have to erase this one for a while. So we have here, okay, 4x squared minus 25. So the factor now is 2x minus 5 times 2x plus 5. Okay. So now we are going to wonder, how do we able to cater with those answer? What would be the pattern? Since they give the previous one having the pattern, so now what is the pattern in working with a factor? So here we have a set of given. So we have here x squared plus 5x. So my question is, how do we able to cater that one? So first thing that we should do here is that we're going to collect the numerical coefficient here. We have here 1 and 5. So since we don't have any common divisor, so the given now here is 1. Okay, so still the same. The common divisor of the two given number, which is 1 and 5, is 1. So 1 divided by 1 is 1. 5 divided by 5, 1 is 5. So it's still the same, just like this. So that is why we have here 1 as the result. In catering the given numerical, for the variable, we have here x squared and x. What is lesser exponent on the two given? So the lesser exponent of the two given is x. So we are now here. We now have as the result x, then 1. Since we have here the common, which is x. So that is why x here that we have, then as we remove the x here, we have here the remaining x is 5 here, and then we have here the 5. So remove the 5, the x. So from that we have now x as the common divisor. So we are going to divide x squared from x squared this is x squared to x, since we are removing the lowest value of the exponent of x, so just remove. So since we have here 1 as the lowest value or the lower value comparing to, so between the two, so we just get the common factor. So automatically the common factor is x. So x squared divided by x, and that is x. 5x divided by x, and that is 5. So that is why x here, then the other one is, the other factor is x plus 5, because of this x then plus 5. Okay, so then here we have 3x squared plus 9x is, so we are going to have 3 9. So 3 9 here is having the common divisor, which is 3. So 3 divided by 3, and that is 1. 9 divided by 3, and that is 3. So we have here x, collect the variables, or collect the literal coefficient rather. So we have here x squared, then the other one is x, so we have here x, the lower valued one. So 3 times x, 3 times this one, and that is 3x. So that is why we are just removing the 3x. So we are just right in the first factor as 3x. So this is now the process. So next thing that we should do for this is we have, since the first given term is 3x, so divide 3x to 3x, because here the product that is what we have here. So to get the second factor, by the way, this is not the process. So 3x squared times 3x, so cancel. So what is remaining now is x. Then copy the 9x, divide by the product here, which is 3x. So we have here 9 divided by 3, and that is 3. Cancel the x, so we have now x at 3. So the second term, the second factor that we have now is x plus 3. So that is why we have here x plus 3. That's it. So in the given example number 3, so we have 4 and 8. The common factor, the common divisor is 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So we don't have any common divisor now. So we have now 4 in the numerical part, numerical coefficient, while the other one is x squared and x. So the lower exponent of the variable x is x. So that is why 4x as the first common factor. So we have to write it here. To have the second valued here, so what we should do here is just copy the given, which is 4x squared, then divide it to the product that we have, which is 4x. This one. So we have now cancel, and we have here the remaining x. So we have to write it here x. Well, the other one is 8x divided by 4x. So we have here this one here, 8x divided by 4x. So 8 divided by 4, and that is 2. Then cancel the x. So that is why we have here 2 as the result. So the product now, the factor now of 4x squared plus 8x is 4x times the quantity of x plus 2. The product, the factor now of 3x squared plus 9x is equal to 3x times the quantity of 3x plus 3. The factor now of x squared plus 5x is equal to x times 5x plus 5. So this is what they call it, the common monomial factor. Okay? I explained it already. So that is how. How about common monomial factor of this? Okay, so the first thing that we should do here for the letter A is we have collect the numerical coefficient, which is 2 and 6. So give the common, which is 3. So 2 divided by, that is not 3 by the way. It should be 2. So we have 2 here. So 2 divided by 2, and that is 1. 6 divided by 2, and that is 3. Then we cannot provide any more aside from 1, the common divisor. So we have now 2. So we have to, since we have here 2, then since we have here 2x divided by 2, and that is x, so we have here to write it here, the x. 6 now divided by 2, and that is 3, positive 3, so we have here plus 3. So the answer now is 2 times the quantity of x plus the 3. Okay, how about in the given example number, a letter B, factor completely. So here we have, I have to put it here. So 14, then the 21. So what is the common divisor? Which is 7. So 14 divided by 7, and that is 2. 21 divided by 7, and that is 3. So we have here 7 by the way. So x cubed, then y squared. So x cubed, so then the other partner is we don't have x, so we could not get the common factor for x cubed, for the variable x, and then the other one is y, then y squared. So the lower exponent of the 2 is y, so that is how y 7y as the common factor, the common monomial factor of this. So I just write the 7y. To have the factor for the second factor, to have the value of the second factor, so we have here 14x cubed y divided by 7y. So cancel the y. 14 divided by 7, and that is 2x cubed. So we have to write here the 2x cubed. Then minus negative 21 y squared over 7y. So we have divisible by divisible by 7, so we have here negative 3. Then y squared and y divided by y, and that is y. So this is just negative now. That is now negative 3y as the result. So I write it properly because it's not yet here. 7y times the quantity of 2x cubed minus 2x cubed minus 3y. We now have factor it completely. Okay, that is for letter B. And then for letter C, since the given is 9a squared plus b cubed plus 15a to the 5b to the 4th minus 18a cubed b squared. So I just collect first those numerical values. So 9, 15, 18 rather. What are the common? The common is 3. So we now have 9 divided by 9, and that is 3. 15 divided by 3 is 5 rather. 18 divided by 3 is 6. So we don't have any common divisor since we only have a common divisor of 3 and 6, but the 5 is not. So we only have 3. So we have here 3 as the first one in the common as common. So we collect all the numerical, the literal coefficient of a. So a squared, a to the 5, then a cubed. So the lower value here is a squared. So I have to write a squared in a. For the B1, the B part is we have b cubed b to the fourth, b squared. So the lower value is b squared. So now we have the common monomial factor is 3a squared b squared. Then we don't know yet the second factor. So we have now, I have to put it here, 9a squared b cubed divided by the common, which is 3a squared b squared. So cancel 9 divided by 3, and that is 3 b cubed over b squared, and that is 3 minus 2, and that is b. So that is why 3b plus the other one is 15a to the 5 b to the 4 over 3a squared b squared. 15 divided by 3, and that is 5. A to the 5 a squared, so 5 minus 2, and that is 3, so we have here a cubed. B to the 4 divided by b squared, b, so 4 minus 2, and that is 2, so we have here b squared. So 5 plus 5a cubed b squared. Next one is negative 18a cubed b squared all over we have 3a squared b squared. So negative 18 divided by 3, and that is negative 6 equals negative 6. A cubed a squared, so 3 minus 2, and that is a. B squared cancel. So we have now minus equals negative 6a. So minus 6a as the answer. So the common factor, the factor now of 9a squared b cubed plus 15a b 8 to the 5 b to the 4th minus 18a to the cube b squared is equal to 3a squared b squared times the quantity of 3b plus 5a cubed plus 5 plus 5a cubed b squared minus 6a. So that is the common monomial factor. So the explanation, other set of explanation, we have here that we have that, but still the same as what we have it here. Okay, we have here a series of activity number 1. So we have to leave that one, and I will be posting that one. The other set of explanation for you to enhance, and we have to compare it later on. Don't forget to subscribe, follow, like, share my video lesson in your account or in your Facebook page, or just to share it to your classmates, to your friends, to other grade year level. It's grade 8 year level that you have. Again, I just make another video lesson for this. Just hold on, just wait for my other set of video lesson rather. So we have here another set of factoring difference of two squares. So we know already that the factoring of difference of two squared, we have here a plus b times a minus b. So we have here a squared minus b squared. Okay, the better explanation for this is that a squared is a perfect square of a. Then b squared is a perfect square of b. So therefore, we have to write a plus b here, since we have no difference of two square. A plus b, the other one is a minus b. That's it. Okay, 9m squared minus 64 is what we have in our given. So 9m squared is a perfect square of 3m, while 64 is a perfect square of 8. So that is why we have 3m minus 8 times the quantity of 3m plus 8. Okay, hold. Sir, is that correct when we write it 3m minus 8 times 3m plus 8? Or is it the same with 3m plus 8 or 3m plus 8 times the quantity of 3m minus 8? So there's no harm at all if we're going to write either, like plus here then the minus here, because in multiplication commutative property takes place. Same as here, a minus b, a plus b. Okay, interchange the positioning. Okay, meanwhile, here we have x squared is a perfect square of x. 49y to the 6 is a perfect square of 7 cubed, because 7 cubed times 7 cubed is 49y to the 6. So that is why we have here now quantity x minus 7 cubed times the quantity of x plus 7 cubed. That's it. Okay, the given for letter D is c squared d to the 4 rather minus 25r squared. C squared d to the 4 is a perfect square of cd squared, because cd squared times cd squared is cd squared times cd squared is cd squared c squared times d squared. So that is why the perfect square of cd squared d to the 4 is cd squared. Okay, 25r squared is a perfect square of 5r. So that is why the answer now is cd squared plus 5r times the quantity of cd squared minus 5r. Okay, that is now the explanation. We have here a guide question. What kind of number is the first term of each polynomial? Perfect square number. Perfect square. Perfect square expression. Same as with the last term. It is a perfect square. Okay? What is the middle sign? So we don't have an... What is the middle sign of the polynomial? Minus. The middle sign is subtraction or minus. So if that would be the case, we could get the factor. If it is plus, we could not get the factor. Okay? We cannot get the factor in some other cases. How was the polynomial factored? Through the use of where can we get the perfect square? So, what pattern did you see in the factors of the difference of two squares? The pattern is same as letter A. The perfect square of a certain expression, of a certain term. Can all expressions be factored using difference of two squares? Why or why not? Can all expressions be factored using difference of two squares? Yes, because if it has a perfect square, then we can get that one. Why can you factor expression using difference? When can you factor expressions using difference of two squares? When we have a perfect square. Okay, number 6, can all expressions be factored using difference of two squared? Not all times, for some cases, because if the given is not a perfect square, if the two terms are not perfect square, then we could not get the factor. Okay, illustrative example. How about this kind of expression? Factor 81x squared minus 144y squared. 9x, by the way, we have to check 81x squared, is it a perfect square? Yes, it is a perfect square of 9x. 81x squared is a perfect square of 9x. 144y squared coming from 12y. So that is why the factor now is 9x minus 12y and 9x plus 12y. Okay? So the activity that we have for activity number 2, I will leave that one in the next video lesson. So hold on and just allow yourself to subscribe my video lesson in the YouTube page, in the YouTube social media platform, because I will be able to post this one. Okay, next is this in factoring the sum and difference of 2 cubed. Okay, we have here the pattern. The first pattern is quantity a plus b times the quantity of a squared minus ab plus b squared. The product of okay, we have to recall, by the way, the special product of this. So when we encounter this pattern, a plus b times the quantity of a squared minus ab plus b squared, we now have a cubed plus b cubed as the product. Same as with, this is not the pattern for the factoring, but this is the pattern for the special product. And we have quantity a minus b times the quantity of a squared plus ab plus b squared. We have here a cubed minus b cubed. What does it mean? Okay, it means that we now have to take the relationship, since we have a plus b or a minus b in the first and the second example, or example in pattern A and pattern B. So if we have encountered here, we now associate the given second factor. Okay, the relationship of this is we have square of, take note that in this first term here is the square of the first term here on the first factor. Then take the product of a and b. Then opposite of that, we have here the result. That is the second term. Then the third term is we have to square the first. So if that would be the case, we have here a cubed plus b cubed as a result. For example, we have here, like the first term, the first factor is x plus 2. If we're out, then like square of the first, we have here x squared, x times 2, and that is 2x. Take the opposite, is we have here negative 2x. Then square of this is we have here plus 4. If that would be the case, we now have cube of the first, cube of this, plus, since this is plus and this is minus, then we can now get cube of x, then cube of 2. So we now have x cubed plus 8 as the result. Next is we have 3x plus 2. So we now have here 9x squared, pattern of that, the square of that, then get the product of the 2, which is 6x, then get the opposite, then square of this, we have here plus 4. So if that would be the case, we have here 3x, the cube of 3x plus the cube of 2. The cube of 2. What I write is square of 2, not the cube of 2. So I have to change this one for a while before we go further. So we have here cube of 3x is we have here 3x times 3x times 3x. So we have here 27x cubed. 3x cubed, we have 3x times 3x times 3x. So that is why the result is 27x cubed, because 3 times 3, 9 times 3, 27. We have here 3x's, so we have here x cubed. So that is why 27x cubed. Plus cube of 8, and that is a cube of 2, and that is 8 because 2 times 2, 2 cubed is just the same as 2 times 2 times 2. That is 8. Okay? So how about using the pattern of this? Okay, let's say 5x minus 3y. So square of the first. So we have 25x squared. 5x times negative 3y, and that is negative 15xy. But then that should be here the positive one, the opposite one. And then the square of 3y, and that is 9y squared. So we could now make use of the result. Cube of 5x minus cube of 3y. Cube of 3y. I already write again the square, not the cube. Cube of 3y. So we have now 5x times 5x times 5x. So we have here 5x times 5x is 25x squared times 5x, and that is 125x cubed. Then 3y times 3y times 3y, that is 27y cubed. So in short, when we have to make use of, if we encountered binomial, to know further about the difference and the sum of two cubes, so there must be a pattern like this in a special product. But then our main concern here is that we're going to interchange the process. So from this part here, this one, it was interchanged the pattern. So it begins with a cubed plus b cubed. Then the result is quantity a plus b times the quantity of a squared minus ab plus b squared. So like this. So the first case is the perfect cube of two binomial terms. Then perfect cube of the difference of two binomial terms. How to work out with that? Okay. So to begin with, so let us try to investigate. 27x cubed is a perfect cube of 3x, right? Because 3x times 3x times 3x is 27x cubed. 1000 is a perfect cube, I think 10. Because 10 times 10 is 100, times 10 is 1000. So we now have a perfect 1000 is a perfect cube of 10. So we now have 3x then the 10. Since it is just 5 plus, so the first factor now is 3x plus 10. How about the second factor? We now have square of this, and that is 3x times 3x, and we have here 9x squared. 3x times 3x. Then we have get the product of 3x and 10. So we have here positive 30x. So the opposite of that is negative 30x. Then square of this one, that is 100. So that is why the result now is quantity 3x plus 10 times the quantity 9x squared minus 30x plus 100. That is now the explanation. So this is now the result that we have. Okay, wait. It is so messy. This one here. This one. Okay. I will give another set of examples. Let's start before we leave for the activity number 3. Like for instance, we have here example how to factor. Let's say we have 64 a cubed b cubed minus 27c cubed. Okay, let us check if this one fits in the perfect cube of a certain expression. 64 is a perfect cube of 4. A cube is a perfect cube of A, while B cube is a perfect cube of B. Meanwhile, here is 27c squared. C cube is a perfect cube of 3c. So the factor now, or the first factor of a binomial is we have here 4ab minus 3c. I will repeat writing this one because it's just so messy and untidy to look at. So we have quantity 4ab minus 3c. To get the second factor is we're going to square this one. The square of 4ab, the square of 4ab is 16a squared b squared. The product of this is negative 12abc. The product of 4ab and negative 3c is negative 12abc. But then since it is negative, as we write it here, the opposite of it. So we have 12abc. Then square of 3c. So we now have plus 9c squared. So this is now the factor of this given. So then again, I will leave your answer this. I will leave your work here. Your work here, and I will leave it to you, and I will explain that when we do then another set of video lesson. Feel free to subscribe my YouTube channel and like it, then have some comments for the future lesson, then click the notification, the bell for your future preference. Okay, so another part is the factoring of perfect square trinomials. So we have here another set of pattern. So we have quantity a plus b quantity squared is equal to a squared plus 2ab plus b squared. Then we have quantity a minus b quantity squared is equal to a squared minus 2ab plus b squared. So in this case, this is just a perfect square. What do you call this? This is just a special product. Special product for the perfect square trinomial. How to expand it? So as we reverse this one in the positioning of this, so it became now a perfect square trinomial in terms of how to factor. So this one is, we have the pattern is we're going to, so if we're going to reverse further, as I said, so like for instance, we have here, let's say for the first one is we have, like for instance, is we have a squared plus 2ab plus b squared is equal to the quantity a plus b quantity squared. So this is just the pattern in factoring, is if we're going to have a reverse order of that. Same as with a squared minus 2ab plus b squared is, we have here a minus b quantity squared. So let's begin now how to analyze further about this scenario in dealing with how to get the factoring. So take note that the first and the last term, or the third term, must be, or the last term and the first term must be perfect square of a certain expression. Then
where it just originated its perfect square value, then whatever the value of it, we're going to get the product. So like for example, we have here, okay, so this example, so that you could understand. So let us try to check this one. X squared is a perfect square of x, while 36 is a perfect square of 6. So if we're going to multiply further the 2, we come up with 6x. Then take this times 2 of that, we have here 12x. If that would be the case, so this one here, this one, and the middle portion of the given expression that we have, so therefore that one is a perfect square trinomial. That is the order, the things that we're going to understand. The first thing is we're going to check if it is a perfect square. Then as we check it, this is a perfect square. The 36 is a perfect square of 6. The x squared is a perfect square of 12 of x. Then multiply the 2, we come up with 6x, and then multiply the 6x always by 2, the product of it, so we come up with 12x. Then since 12x is the same as the middle, so we could now conclude that this one is a perfect square trinomial of x plus 6 squared, x plus 6 quantity squared. That's it. That is how we deal with the given situation or the given expression as we go on with our checking with respect of how to identify with this one. Or in other way around to write this one is just we say x plus 6, as then the other one is x plus 6. So that is now the answer in how to factor the x squared plus 12x plus 36. Another one is the given example is factor 4r squared minus 12r plus 9. So let us check. First thing we should do is try to investigate this one. 4r squared is a perfect square of 2r. Why? Because 2r times 2r is 4r squared. 9 is just a perfect square of 3. This is 3. Okay, this is r. Okay, then following the pattern that I have shared with you previously, so we're going to multiply the 2, so we come up with 6r. Always times 2. The next thing is we have 12r as the result. Since this is in the middle, the given is minus, so probable answer that we have now is 2r minus 3 quantity squared, or just we say 2r minus 3 times 2r minus 3. And so that is how we cater here. That is how we come up with the answer. Take note that, by the way, if the middle term here is positive, then it should be plus. While in this case here, if the middle of this part here is negative, then here the answer must be minus sign. Those are the things that you're going to understand and put into your mind how it catered with the results. Okay, so let's move on. So the generalization of this we have here. Remember that perfect square trinomial is the result, the square of the binomial, as I showed it previously. Okay, now what would be now the result here? Let's check. Everything must be checked, because how do we able to claim that one would be the result if we don't know it yet? So d squared is a perfect square of d. 36 is 6. So 6 times d is 6d, times 12 is we have here, times 2 is we have 12d. So therefore this is a perfect square. So we have now d plus 6. 16t squared is a perfect square of 4t. while 9 is a perfect square of 3. So 4t times 3 is 12t. Multiplied this one by 2, multiplied by 2, multiplied by 2. So we have here 24t with a given minus sign here. So this is a perfect square trinomial. So as we supply the missing term to make it a true statement, so we come up this one as 4t minus 3 quantity squared. X to the 4 y squared is a perfect square of x squared y, because x squared y times y is x squared times y quantity squared is, okay, wait, for it to be able to not to have no problem at all. So I will be able to change this one. Okay, so since we cleaning that one as a perfect square, so meaning to say x squared y times x squared y is equal to x to the 4 times y squared. So therefore x to the 4th y squared is a perfect square of x squared y, while 9z squared is a perfect square of 3z. So multiplying the two, we come up with x squared y times 3z is, we have here 3x squared y z. Multiplied by 2, we come up with 6x squared yz. So since this is just the same with the middle and it is a minus sign, so therefore this is x squared y minus 3z quantity squared. Next is 9n squared, given is 9n squared plus 30nd plus 30d squared. So therefore 9n squared is 3n, perfect square of 3n. 25d squared is perfect square of 5d. Multiply them the two, so we come up with 15nd times 2, we have here 30nd. So therefore this is just the same, so there we have here now 3n plus 5d quantity squared. For the given problem for number 5 is 4x squared plus 4x plus y squared. So 4x squared is a perfect square of 2x, while y squared is a perfect square of y. So multiply the 2, we have here 2xy. So 2x times y is 2xy times 2, we have here 4xy. This is the same with the middle. So therefore now the answer is 2x plus y quantity squared. So that is now the activity given, or that is the answer of our activity given. So we also have how to factor general quadratic trinomials. So we have here 5 given that we have factor m squared plus 5m plus 6. So we have to make use of the diamond method. So when we say diamond method, when we have ax squared plus bx plus c, so we come to get the diamond method is we have here ax squared, then a times c, then we have here b. So that is now the pattern as we go through. So given this one, so as we make use of this, so following this one as m squared. So since whatever the value here, the first term, the quadratic term that we have, so ax squared. So since the given here is m squared. So by the way, the value of our a here is 1. Our a here is 1. B for the middle term is 5, while C is 6. So therefore we have here A times C. So to get the upper portion, the product of the upper portions, we are going to multiply A and C. So 1 times 6, and that is 1 times 6, which is A times C. So 1 times 6, that is 6. Then copy the 5. That is how we cater with the given result or the given problem that we have. Okay, so next part is we're going to have to work out with get the product of get the factor of 6. So 1 times 6, 2 times 3. Okay, here 2 times 3, 1 times 6 times 1, negative 2 times negative 3, negative 6 times negative 1. So the next thing that we should do is since we cater about now the product, the factors of 6, so it should be the sum must be the same with 5. So 2 plus 3 should be what is the sum? So 2 plus 3 is 5, 6 plus 1 is 7, negative 2 plus negative 3 is negative 5, negative 6 plus negative 1 is negative 7. So since among the sum here, the value of this one here is the same as here. So now we could say something that this, okay, I stand corrected here. So this must be this must may not be x squared. I think this is a squared. Okay, ax times ax. That's it. Okay, so m. So now since this is just the same with the 1, so we come up with over 2 over 3. So since we could not simplify this one, m over 2 and m over 3, so therefore we could say that the factor of m squared plus 5m plus 6 is the same as m plus 2 m plus 3, the fraction given that we have. Okay, that's it. That is how we cater with the diamond method that we have. So we have now in the another case of the factoring the quadratic trinomials when we have a greater than 1 value for the quadratic term. So as we go through with the second example, factor 6x squared minus x minus 2. So our value of our e here is 6, b here is negative 1, c here is negative 2. So what we have now in the diamond method is we have here ax, ac, b. So here we have, since the value of our a is 6, so 6x here, 6x. The product of a and c is negative. 6 times negative 2. 6 times negative 2, we have negative 12. Then we have here negative 1. So we are going to get the factors of negative 12, this one here, this one, wherein the sum must be negative 1. We are going to get the factors of all of negative 12, wherein those factors, as we add them, we come up with negative 1 as the result. So that is how the process takes in. So now here we have the catered all the factors of negative 12. So we have here 1, negative 12, negative 1, 12, 2, negative 6, 2, negative 6, 2, 6, 3, negative 4, negative 3, 4. So we have here negative 11. Taking the sum, 1 plus negative 12, negative 11. Negative 1 plus 12 is 11. 2 plus negative 6 is negative 4. Negative 2 plus 6 is 4. 3 plus negative 4 is negative 1. Negative 3 plus 4 is 1. So since our value of b is negative 1, so this is now the result that we have. So now, as we go back, so the factors that we only have one possible factor that could fit in the given expression, and that is 3 and negative 4. So as we go back there, so the 3 and negative 4, we have to put it here, that one, 3, negative 4. Write that one as our denominator of the denominators of our 6x. So after which we are going to simplify, divisible by 3, so this is 2, this is 1. This is divisible by 2, 3, this is negative 2. So the fraction now that we have here is 2x over 1, and the other one is 3x minus 2. So therefore, now as we have here the factor now of 6x squared minus x minus 2 is equal to 2x plus 1, here 2x plus 1, and then we have here 3x minus 2, using the diamond method. So other books, this is called as diamond method. Using the diamond method. So that is now the factor given for the for this example that we have. Okay. So we have here that one, 2x plus 1, 3x minus 2. Okay. I will leave your some of the problems here. And by the way, I have posted another set of discussion about the factoring quadratic trinomial in my previous video lesson that I have. So feel free to catch it or to watch it in my video channel in the YouTube social media format. Okay, we just pick first the number 1, then we leave that one, the other portion for your own enhancement. Okay, A here is 8, B here is 2, C here is negative 3. I will post another set of lesson for this for your own enhancement. Just then we are going to compare further as you go through. Do not forget to subscribe my channel in the YouTube social media format, and then don't forget to click the notification bell for your future reference. Okay, so we have now here 8x here, 8x here. So multiply 8 and negative 3, so we have here 8 times negative 3, and that is negative 24. Then copy the 2. So we're looking for the factors of let's say we're looking for the factors of negative 24 such that the sum must be 2. So we have here 6, negative 4. So we have these are the factors. Its sum is 2. Okay, by the way, we only get automatically, so therefore I can no longer exhaust everything, all the factors of negative 24, because as we get the sum, among those, take note, among those all the factors given as you exhaust it, as you work on it, we only have one possible value for the factors of the given problem, a given expression, and that is 6 and negative 4, because the sum of these two is 2, same as in the lower part. So that is our basis. So now we have here 6, we have here negative 4 as the pattern takes in. So simplifying them, this is divisible by 2 rather, so this is 4 and this is 3. So it became now 4 over 3, 4x over 3. Then the other one is negative 1, then 2. So we have here 2x over negative 1. So this one now, the factor of that one now, the factor of 8x squared plus 2x minus 3 is 4x plus 3, 2x minus 1. Okay, if we're going to check them, so 4x times 2x is 8x squared. 3 times negative 3 is 3 times negative 1 is negative 3. 3 times 2x is 6x. 4 times negative 1 is negative 4x. 6x plus negative 4x, and that is 2x, which is the same with the middle. So this is now the correct work, which is 4x plus 3 and 2x minus 1. Okay, so let's move on now in how to solve problem involving factoring. So the given was this one, 12 decreased by 2, 12 decreased by twice a number is 2. Okay, 12 decreased by twice a number is 2. In order to translate the following, so we have here we have here 12 decreased by twice the number is 2. So we have here 12 minus 2n is equal to 2. Then after which we are going to gather some sort of information involving how to solve the problem. So this is one now the given task that we have, the given mathematical representation, 12 minus 2n, which is equal to 2. So from here 12 decreased by twice a number is 2. Okay, so we're letting the unknown value, which is represented by n, so that one. Then as we gathered information, so we have to make now representation, mathematical representation, then the equation further, then how to solve further, verify the answer, so using the zero product property. So we now have that so we now have that one, since we are just only translating from the verbal statement to mathematical statement. So we have here another set of example, which stated as the given example is the square of a positive integer less than twice the next consecutive integers. Okay, this one. Okay, the square of a positive integer is less than twice the square of the next consecutive integer. So we have here that as we identify what are the integers, so as we identify the given problem, we come up with two sets of consecutive positive integers. So as you can see here, this one is, we let the first integer to be x, the next of the integer will be x plus 1 as a positive integer. So the square of a positive integer, so the square, then the first positive integer is squaring that one, then twice the square of the next consecutive integer, twice the square. So we have here x square of x plus 1, then twice of it. This is now twice of the square of the next consecutive integer. Now, and it's stated there the mathematical representation. So this is now the mathematical representation. So the equation that we are going to translate from this verbal statement is the square of a positive integer. So we now have here x squared, then we have here twice of x plus 1 squared. So we come up with the, so as in this verbal statement, so we have here twice of twice the square of x plus 1 minus 98 is equal to x squared. So we have that, or x squared is equal to twice of the square of the next consecutive integer minus 98. So after which, so how to solve a certain problem as we work it out. So in this case, involving this one, this 98 here, we have to make use of plus 98 here, plus we're taking the plus 98 here. Now, so this one make it 0. So if we're going to have this one eliminated in this left side, so we're going to add negative x squared. So save us here, negative x squared. So that is why what is the remaining here is we have quantity, so it just the same with the interchanging the positioning. So we have here 2 times the quantity of x plus 1 quantity squared minus x squared is equal to 98. So expanding this one in our special product, so we have here 2 times square of x is x squared, twice the product of first and the second term, so x twice of it is 2x, then square of the second term, which is 1, minus x squared is equal to 98. Then after which is we're going to distribute. So 2 times x squared is 2x squared, 2 times 2x is 4x, 2 times 1 is 2, minus x squared equals 98. Then after which we have here x squared plus 4x, because 2x squared added to negative x squared is 2x is x squared. Copy the 4x. Then we have here equating it to 0, so we have here 98 plus 98 minus 98, minus 98 minus 98, so we have here that one is making 0. Then negative 98 plus 2 is we come up with negative 96 is equal to 0. So after which is we have here making use of that, so a, this is our a here, this one 1, b which is 4, c is negative 6, we have here negative 96, so we have here x negative 96, so the sum must be 4. So the only thing we have is 4, 12 and negative 8 with the sum of 4. So that is why x plus 12 is the first factor, while the second factor is over 12 over 12, then over negative 8. So that is why we have here x plus 12, the first one, then x minus 8, the second one, is equal to 0. So equating both factors to be 0. So x plus 12 equals 0, x minus 8 equals 0. So we come up now with x is equal to negative 12 and x is equal to 8, because we're going to transpose the 12 to the other side, so it became 0 plus negative 12, so we come up with negative 12. Here we have transposing negative 8 to the other side, it became negative 0 plus 8, and that is 8. So since the given, as we go return it back to the given equation, the given problem, it should be positive integers. But here in this given problem, we could cater everything, the two given answers, that the negative 12 and 8. So this, we are going to discard this one or reject this one, because what we catered here, the given example or the given problem, is positive. So that is why we are rejecting this one, because this one is passable, because this negative 12 is negative numbers while the 8 is a positive value. So the value of the first is 8 and the second is 8 plus 1 and 9. So because we have here two values of what we're looking at here in the given task, is we're working for the two consecutive integers. The two consecutive integers now is 8 and 9. So therefore, so as we use this one, the square of the first, so the given task is twice the square. So twice the square of 9 minus 98 must be the same as the square of 8. So 81, 2 times 81 minus 98, and that is equivalent to 80, what you call this, 64. So therefore 162 minus 98, and that is 64. So therefore 64 equals 64, as we verify the sort of equation. So we could now claim that we could say something now that the answer that we are looking at is 8 and 9. Okay, so I leave your work, that let us practice here for your own consumption, for your own good. You have this one here. Let us practice more. Let us remember. Let us assess. Okay, let us assess. So there is some sort of explanation for that for the next video. So feel free to watch it over as we go through. So let us reflect, and we have here some sort of answer key for your enhancement of this module, for you to be able to understand it well. Hope you enjoy this one as we continue working it. So thank you so much guys for your listening and for watching this video. Feel free to have some comments and suggestion for your own consumption and for your own preference, and feel free to share this video to other classmates or other friends of yours, for you to learn, for you to share. Take note that sharing is giving. Hope you enjoy it. Goodbye for now, and let's continue working it on the next video.